I'm going to start off with some super basic division, so follow along. Now we're going to review some of the division terms. For example, the quotient is the answer, dividend is what's in the house, the divisor is outside the house, and the remainder is at the bottom. Not only that, but each little piece of the division problem has a letter that corresponds to it. Just remember the letters because it'll be important right now when it comes to division algorithm. So as you saw previously, the quotient was QX and so on. We're going to put all those together and put it into a format that we have. For example, the fx is the dividend, the dx is the divisor, the quotient is the qx plus the remainder over the dividend again. Now we're actually going to start our long division with the polynomials. It's basically the same thing as the long division with just basic numbers, but it just has a little more extra to it, the letters and the variables into it. Just follow along and hopefully you'll understand because it'll be written out for you. Those little circles right there, you have to make sure that you change the signs each time, like before you subtract, because that's very important. If you don't, or if you forget to, your entire problem is going to be screwed up. You'll have weird remainders and stuff like that. Just remember to change the signs before you subtract, okay? As you can see right here, we have no remainder. Now you got to get those three pieces on the top of the house and inside the house, and we're going to use it as our answer. Look at the red, and as you can tell, that was what was outside the house earlier. You're going to take your answer or the quotient and factor it and set it to 0. Now there may be some instances where the polynomial has like missing terms and stuff. Just make sure you fill it in with zeros, like as you can tell right here. And then after that, just continue with your long division. All that long division was kind of, long. Luckily, synthetic division is much, much easier. So our problem is telling us to use synthetic division to divide this polynomial by x plus 3. First thing you're going to do is set it equal to 0 so you can have the number that will go outside of the house this time. And you're going to use the equation that they gave you and take the coefficients from each one and put it on top of the house. It's kind of like an inverted house for this time, but it's much, much easier for synthetic division. What you're going to do, first you're going to bring down the 1 and multiply the negative 3 outside the house to the 1, which is negative 3, and bring it under the next term. And then add that together. So what you get is negative 3. Then you keep going with the same pattern, keep going, just make sure to be careful with those signs, okay? So you add, and then you get that, and multiply, keep going, add, keep going until you get to the very end or the last term. It depends on the problem if you do get a remainder or not. And take those numbers on the bottom, and sorry I ran out of space, but you're going to take those numbers at the bottom and start over. Not really start over, but write it up again, because this is how you're going to format your answer. You see those, you're going to go in order from x to ascending order. So it's going to be x cubed minus x, 3x squared minus x plus 1. That's going to be your quotient and your answer.
The remainder and factor theorems. The remainder theorem. The remainder theorem is obtained when we do the synthetic division process. The remainder theorem states that if a polynomial f of x is divided by x minus k, the remainder is r equals f of k, where r is the remainder and k is just a number. Let's work on an example. F of x equals 3x cubed plus 8x squared plus 5x minus 7. We're going to use synthetic division to work x equals -2. So set up your division and go through the process, and you should end up with -9. This is your remainder. Because r equals 9, we can say that f of -2 equals -9. Remember, r is your remainder and k is just a number. So we can say that -2 and -9 is a point, where -2 is f of k and -9 is r. This is a point on the graph of f of x. Any remainder that you get will be a y value To check your answer, you can just plug in x equals -2 into the original function. The factor theorem. The factor theorem states that you can test whether a polynomial has x minus k as a factor. The factor theorem states a polynomial f of x has a factor x minus k if and only if f of k equals 0. So let's show that x minus 2 and x plus 3 are factors of the following polynomial. In our first step, we're going to use synthetic division on this polynomial for the factor x minus 2. So set up your division process. And we get a remainder of 0. If we get a remainder of 0, we can say that x minus 2 is a factor of f of x. In our second step, we're going to take the result of the first division process and divide again 4x plus 3. So remember, this was the first division. And we're going to take that result and perform synthetic division again for negative 3. Again, we get a remainder of 0, so x plus 3 is also a factor. This is our third step, and what we did is what we're going to do is factor the resulting quadratic from the second division process. In your final step, you're going to write the complete factorization of the polynomial.
Okay, we're going to find the possible rational zeros of the polynomials. To find the possible rational zeros, you have to take the factors of the constant over the factors of the leading coefficient. Let's try the first example. It's going to be f of x equals x cubed plus x plus 1. So x is going to be your leading coefficient, and 1 is going to be your constant. Your only possible zeros are going to be plus 1 and minus 1. So to find if they are rational zeros, we're going to plug them in. Now you see that f of 1 equals 3, which is not a zero. Let's try negative 1. F of negative 1 is not a rational zero either. So f of x does not have any rational zeros. Okay, let's try a second example that will have some rational zeros. F of x equals 10x cubed minus 15x squared minus 16x plus 12. So you're going to take the factors of 12, which is your constant, and the factors of 10, which is your leading coefficient, and list them out. Remember to put plus or minus because you're counting both of them. Okay, so we're going to take all the ones. So 1 over 1, 1 over 2, 1 over 5, 1 over 10. Now move on to the 2's. Do 2 over 1. 2 over 2 equals 1. You already have it, so move on. 2 over 5. And 2 over 10 is 1/5, so you don't have to rewrite it. Now 3 over 1, 3 over 2, 3 over 5, 3 over 10. Then 4 over 1, you already have. 4 over 2 is 1/2. So move on to 4 over 5. 4 over 10 is 2/5, so 6 over 1. 6 over 5. Then you already have 6 over 10, which is 3/5, so move on to the 12s. Now we're going to list off all the possible rational zeros, starting with the whole numbers and then the fractions. Remember to put plus or minus in front of all of them. And we're going to start with trying out the whole numbers because it'll be easiest. We're going to use synthetic division, so I'm rewriting our original polynomial. And we're going to start with 1. So 1 is not a 0 because you cannot have a remainder once you do the synthetic division. It has to be 0. Now let's try out 2. And you're going to see that 2 is a rational 0. So that means that x minus 2 is a factor of the resulting quadratic. We're going to rewrite it up here because we're going to use the quadratic formula to find the other two zeros. So your answer is going to be x equals negative 5 plus the square root of 265 over 20, which is approximately 0.56, and x equals negative 5 minus the square root of 265 over 20, which is approximately negative 1.06. So this is the complete factorization of the three zeros.